Hello, my name is Brandon, and today I'm here with Sean, Ben, and Christian. Together, we are Group Lenny, and today we will be doing an overview on what a forest plot is and how to interpret its findings. Please take a look at these gentlemen right here. Don't they look confused? That is because their teacher gave them a blobogram to look at, and they have no idea what that is. No worries, gentlemen. Group Lenny is here to help. For starters, this is a picture of an example forest plot that we will be using today. Circled in red on the left is the list of studies. This will be our starting point for discussing what a forest plot is. A forest plot shows results from what is known as a systematic review or a meta-analysis. Researchers use forest plots to combine multiple studies that address the same question. The studies are typically arranged in alphabetical or chronological order. Each study that is used in the forest plot is typically weighted, and the weight for each study depends on how significant the researchers determine it to be.
Visually, the weight of the individual study is depicted by the size of the black squares seen here in the red circle. The location of the squares represents the mean result of the individual specific study, and the horizontal lines extending from each square represents the spread of data within the confidence interval for that study. This graphical spread is often known as the confidence interval whiskers. At the bottom of the graph, there will often be a black diamond, which represents the overall estimate of the meta-analysis seen here in the red circle. The location, side to side, and size of the diamond can be used to view the results of the meta-analysis as a whole in picture form, and the dotted line often seen on the graph represents the average of the results from all of the studies included in the meta-analysis.
The red line in this diagram is pointing to the line of null effect. This is a vertical line in a forest plot, which I will be discussing on the next slide. When interpreting a forest plot, we now move on to one of the more important features that you can see on the graph. Pictured here is the vertical line known as the line of null effect. This line is placed at the value where there is no association between an exposure and outcome, or no difference between two interventions. Relative statistics have a null effect value of 1. For absolute statistics, like absolute risk, the null difference value is 0. Hence why the value at the line of no effect is relevant to this type of statistic being used.
So now that we know how to interpret a forest diagram, let's take a look at an example. Here we can see a forest plot diagram that's depicting implant failure associated with diabetes. And we can see that there are 5 studies here, however only 4 of the studies are shown on the diagram. And looking at the left, we can see that, that each study is organized based on alphabetical order. And if you look towards the middle underneath risk ratio, we can see that we're working with a 95% confidence interval. And 2 of the studies, El Sahadi and Honor, favor diabetes, whereas the bottom 2 studies, for Morris and Tawil, favor non-diabetes. And you can see that the Morris study has the greatest weight of all these studies. And thus, when we combine all these results, we see that the overall estimate comes to a significance value of 0.07, meaning that their study for implant failure associated with diabetes was non-significant.